In this video lesson, we're going to talk about displaying data when you're writing up your formal lab reports. When you're doing your experiments in class, you're going to organize the data you collect into something called a data table. Now, these tables may vary depending on what your organization is and what kind of data you're collecting, but they do have some general features in common. The first thing you're going to include with your data table is a specific title. And this is an important part. Students tend to generalize the title. You want a title that's specific to the data that you're collecting. So a title should say something about the data that's contained inside the table. When you're organizing your table, generally the dependent variable is listed at the top of the right-hand column, and units are also included with whatever it is that you're measuring within your experiment. So remember, the dependent variable is the variable that the scientist is measuring in the experiment. On the left-hand column, generally we place the independent variable, and again, along with any units that are being used, if that's required, you would put that here, and then we list the independent variable in the left-hand column. You fill the table in with the data that you're collecting, and then the last thing we include for data tables is something called a figure legend. This might be new to you, but what a figure legend is just a statement that we place at the bottom of the table that gives the reader a general idea about what the data is, what we're collecting in this experiment. So let's do a little example where we put all of these features into a data table. This particular experiment is looking at average plant growth in different pHs of soil. So what you'll see here is that the independent variable is placed in that left-hand column of the data table, and the dependent variable is placed on the right-hand column. And what we're looking at here, a scientist has set up an experiment in which he's changing the pH of the soil from a pH of 6 to 7.2, and he's measuring the average plant growth that corresponds to those pH levels. Now, what pH is just a measure of the acidity of the soil. So he's changing the acidity of the soil and seeing what happens to plant growth. Now, what we need to do when we're gathering data and creating our data table is to give all the features that we need to include in the formal lab report. So let's take away some of this clutter. What we're going to need is a specific title for this experiment. So if we take a look, maybe an appropriate title might be average plant growth over a range of pH values. Okay, and as you can see, that title is specific to the experiment. So we're not doing anything general. Anyone looking at that title can have a fair understanding of what data is going to be contained within the table. We have our labels for the independent variable, the pH of the soil, and the dependent variable, the average plant growth. So now what we have to add is what we call the figure legend. So what you do for a figure legend is just underneath the data table, you would put fig, which is a short form for figure, and if this is the first table or graph in your lab report, you would call it figure 1. So we'll call this one figure 1, and then we would just write a simple statement to let the reader know what it is that's contained within that data table. So we might say something like, the above data table illustrates the average plant growth over a pH range from 6 to 7.2. Okay, and then we would just simply arrange that to be appearing below the table. Okay, so you can see we have our specific title, we have our data with the independent variable in the first column, the dependent variable within the body of the table, and the figure legend below describing to readers what exactly is contained within the table. So for every experiment that you do in the course and that you have to write a formal lab report for, you're definitely going to include a data table. Now you can see from this data table that while the information is there and I can spend some time analyzing it, this really isn't a very visual representation of the data. I don't get a really clear image of the change in plant growth from the data table. So to give a better kind of visual image, we would convert that information from the data table into an appropriate graph. So the two kinds of graphs that we're going to use in science, more or less, are the line graph and the bar graph. And students sometimes struggle with which graph to use when. So if you just can kind of remember that if the data changes over time, then generally a line graph is the appropriate graph to use to illustrate that data. But if you're comparing categories of data, then the bar graph is the way to go. Regardless of the graph that you use, there are some, again, standards that all graphs are going to have. And again, all graphs are going to have a specific title. And again, that title is going to reflect the data. You're not going to call it a line graph or a bar graph. You're going to pick a title that reflects what the data is showing. You're going to include a scale. And that scale is going to be evenly divided, whether it's on the x-axis or the y-axis. And you're going to make sure that you choose a scale that's appropriate for your data. And what you want to do with scale is make sure that the data points are spread out over the graph. So pick a scale that's going to spread your graph out over the majority of the graph axis. And again, we have our variables. So what we have is our independent variable along with the units that's being used to measure, and that goes on the x-axis or the horizontal axis. We also have our dependent variable with the units, and that goes on the y-axis or the vertical axis, and that is always the way that you graph the independent variable on the x-axis or the horizontal axis, and the dependent variable on the y-axis or the vertical axis. Within the graph, you are going to accurately plot your data points. Be very careful and make sure that the graph is accurately reflecting your data. And then again, you're going to describe the graph with the figure legend underneath. So let's take a look. Here's an example of a line graph of a particular experiment. And again, if you take a look, they've labeled the axes with the independent and dependent variable. In this case, the independent variable is the days of the week, and the dependent variable is temperature. So this particular experiment has measured temperature change over a week of time. And they've plotted their points, and notice that the units are included and the axes are evenly divided. So what we want to do here is add the features of the graph that we want to see in a completed graph. Let me just get some things out of the way here. Okay, so we want to add our specific title, and you might say temperature change over a 1 week period. Okay, and that's a specific title that's reflecting the data contained in the graph. The other thing we want to add is a figure legend. So these, again, are placed underneath the graph, and since in this example it's our second figure of our write-up, we would call this figure 2. The data table is figure 1. And again, we would describe what the graph is containing. So we would say the above graph illustrates and you might want to give extra information if you have it. So maybe it's over a 1 week period in Leamington, Ontario. Okay, so any extra information you can include in your figure legend to shed light on that data. But you'll notice that we don't really make conclusions in the figure, we just tell people what the graph is about. Just kind of focus their attention on what they should be seeing in the graph. So this would be a nice graph that includes all the features that we want to see. Okay, so remember specific title, axes that are labeled and include the units, an evenly divided scale that's spread out over the size of the graph, a figure legend that's describing what the data is about. Okay. Line graphs can be more complicated. You can include a double line graph. If you're going to do that, then you also want to include a legend. So this is different than a figure legend. Your legend is indicating what the different lines on the graph are representing. So again, this is temperature over a 5-day period, and the red indicates the high temperature, blue indicates the low for the day. So we would fill in again a figure legend to make this complete. And I want to call attention as well to the line break that they're showing here. If you are not doing if you're doing a scale where the numbers jump, you can include this line break. But notice after the line break, the scale is even. So it goes 50, 55, 60, 65, 70. They're going up by 5s every time. But this line break tells people we didn't really need these lower numbers. We're going to skip them and start at a number that's relevant to our data. You can do that if it is necessary and if it's appropriate to the graph. The other kind of graph that we use in science often is the bar graph. And again, we're using this if we're comparing categories of data. So remember, if it's data that's changing with time, a line graph is probably more suitable. But if you're comparing categories of data, then the bar graph is the way to go. So again, you'll notice that the independent variable is along the x-axis. The dependent variable, or what's measured, is along the y. And let's take a look again at some of the features. You'll see an evenly divided scale. You'll see labeled axes, so we're clear on what the different bars are representing. And what I want to point out with the bar graph as well, in my class, when you're making a bar graph, I want you to make sure that you're using even spaces in between the bars. You notice every bar is separated by a space. Those spaces are equal between each bar. And there's also a space left between the first bar and the axis. I do not like to see the bars right up against the axis, so leave a space there and then equally space every bar thereafter. You'll also notice that the bar widths themselves are equal. So that's another factor to consider. Make sure that your bars are equal width and make sure that the data again is accurately plotted. So of course, for this to be complete, you'd have to add a figure legend. And in this case, this is our third figure, so you would call it figure 3. And then you would do your description. And you give it whatever description is appropriate for that data. So these are just a few of the details to think about when you're making graphs for your lab reports. And again, we have, in this case, the specific title that's telling us what the data is about. And again, bar graphs can also get more complex. In this case, you've got a bar graph reflecting data for both boys and girls. And again, if that's the case, if you're making it more complex, you're going to have to include a regular legend showing what those color codings are meaning. So again, you've got your dependent, you've got your independent. So this particular researcher is looking at different sports, and they're polling the number of students who either participate or enjoy those sports. So again, what you would need to have is a specific title to complete that graph, and you would also have to include a figure legend. Okay, and those are the features that I'm going to look for in your written reports when you're making graphs. Now, when you're doing the graphs, some of them we'll be doing by hand in class. If we're using whiteboards, you'll have to be able to generate these graphs by hand. But if you're doing the formal lab report, you can turn to electronic resources to generate your graphs. And you can find all kinds online graphing for kids. There's a site that allows you to pick the graph type and they'll generate it for you when you put in the data. That is fine. You should also be very familiar with using the table function in Microsoft Word or in Google Docs. So again, take some time to familiarize yourself with making tables in those programs. and use Google again to give you instructions on how to make the tables that you want to generate. And if you need help with that, do come and see me and I'll give you some pointers on how to use those features in the software. Okay, and that is generating and displaying data, and I hope this video lesson is helpful.